Alright, I've done a lot of fiddly work to this thing. I'm just about to button it up, but the speaker connection there, I don't like the look of that heat shrink on there, and there is a bit of exposed metal on that splice there, which can touch the chassis if it was manipulated a certain way. So I've got some new cloth covered wire, which, yeah, it's a bit shiny, bright compared to the old stuff, but it'll be better than this arrangement. We'll get a bit of heat shrink on there, and then maybe replace those grommets too, because they're almost like plastic now. They're so hardened. Particularly on the primary side, which is a bit of a pain in the ass, but I'd rather that than have 400 and something volts to the chassis. Alright, so here's the finished product. You can see some of the parts reused. I ended up going with a replacement carbon composite there for the failing plate load. I found one that was pretty close. It was like 102k. Just to try and keep some parts original as possible. Obviously, we've got the new V-shays there. I've gone with a 4.7 microfarad for V1. Just to tighten up a bit of flub. And we've got the tube amp doctor filter caps there. We've gone back to 16 microfarad as per the original schematic. And you can probably see under there just a little smear of silicon under there to stop them from vibrating. I just replaced the droppers with wire wound because they're good for stability, and lifted them off the board a little bit for some airflow since they do dissipate a bit of heat. And the biasing resistor down there on the cathode, just hung it past the board as it was before to allow maximum airflow too. They've got really thick leads, so I don't think there's any concern about vibration damaging them or anything. Hiding down there, we've got the little backup diodes, 1.5 kV. Cleaned up all the wiring on the rectifier socket. Nice little solder joint there for the safety ground, as well as the center tap and heater ground. I've replaced that wire, the one that was coax. I reckon the reason that they put that there was because this shorting jack wasn't shorting when nothing was plugged into it, so they thought it was an oscillation issue, but it was just that contact was wide open all the time. And replaced that white small flimsy PVC wire with a cloth wire as well, just for the original look. I know they stand out a little bit at the moment, but at least they're the same wire type now. Redid all the solder joints. A few of them were hiding some dried joints, some cracked joints, and just really closely looking at them, particularly on the preamp valve sockets. Moving the wires around a bit, you could see that they were literally loose, so that couldn't have helped either. You sort of have to go over everything of something this age. Reused the film caps, and we've actually passed them through the eyelets. I bought myself a little bit of extra lead length by bending the lead a little closer to the body. There was like a good 1/4 inch of straight lead coming right out of the body, and they were sitting up in mid-air as a result. So that bought us a bit of extra length, so we didn't have to tack solder them. That worked out well. And here's our mains wiring. As per usual, the neutral always connected to the transformer, the active to the fuse tip, fuse ring to the switch back to the transformer. And the ground switch is just left disconnected. Cleaned up a bit of the lead dress, particularly on the valve sockets, but some around the input jack here too. And the pot's cleaned up great. That little Astron, I actually tested that with the high voltage insulation tester, and it's still good, believe it or not. It's almost like if the Astrons aren't exposed to high voltage, they stay good. Could just be a bit of a luck of the draw thing too. All the valves tested okay. A little bit microphonic on that 12AT7. We'll see how it performs in the cab, but with that shield on it, it might dampen it down a little bit too. And special thanks to Seth for the information regarding the signature there from the builder, the initials. It looks like it's Lydia Sanchez James, Lily for short. So she worked alongside Lupe, did very nice work as well. If you could give us a little bibliography there, Seth, I'd appreciate it. But he tells us she was one of Leo Fender's first and most highly skilled amplifier assembly workers. She passed away in 2015 at the age of 85. Lily started working for Leo Fender back in the late 1940s, and she left the job at Fender CBS in the 1960s. So quite the stint there. It's really humbling to look at these units and know the stories behind the people who built them. And then Gooden had his joke about pictures of Lily, but she actually died in 1929, Gooden. So yeah, different Lily. Oh, just some Murata champions. I think I mentioned in one of the videos, I did put it in the description to correct myself, but I mentioned lack of grid stoppers. I was actually referring to every version of the Deluxe before this version. The 5E3 was the first one to have grid stoppers on the 6V6s. I was yammering on about that, but then during editing, and you got to remember I do edit at like 10 p.m. I try to tighten up the monologue. I try to tighten up the narrative a little bit just to shorten the video, make it a bit more clear and concise. I know this is with that editing, mind you. Imagine if I didn't edit anything, it'd be like one of my rambling live streams. But in the process of tightening up the narration, I sometimes clip in and out relevant stuff. And I think while I was probing around, I mentioned something about a negative feedback resistor. Everyone knows a friggin' 5E3 doesn't have negative feedback, but I was working on a Princeton Reverb previous, and that's got a similar cathode ion with negative feedback. So I still had that in my head. But anyway, I'm a dumbass with a soldering iron. You guys know that by now. Don't come here if you want 100% accuracy, that's for sure. Yeah, so obviously no feedback resistor in a 5E3. All right, champions, let's fire it up. It's that time. All right, so you can see there the voltage jumps way up, like 492, I think, at peak there. The caps are rated at 475 continuous, but they've got a peak rating, usually about 20% above that. Just as usual, measuring the primary voltage drop across the output transformer, and it's biased at about, I've already calculated this, around 110%. However, the most power we can get out of it at 8 ohms is about 8 watts. At the onset of clipping, if you really push it into hard clipping, you'll probably approach about 10. If I change that to 4 ohms, just parallel the second 8 ohm load there. Now the roundover is starting at just under 7, about 7 volts, which works out to just over 12 watts RMS, which is what we'd expect from the unit. So she's got a 4 ohm output transformer. Now, as far as I'm aware, the factory configuration was an 8 ohm output. It does have a secondary jack, so if you plugged in a extension speaker, you'd be running 4 ohms. But Fender's always played a bit loosey-goosey with the old impedance. It's usually off by 1 if you do that. Off by 1 notch, like 8 to 4 ohm or 16 to 8 ohm, that kind of thing. And it is the original speaker by the looks of it. Thank you for commenting, legends. I leaned on the comment section and you guys did a bit of groundwork for me. And it looks like an original Jensen from the era. And it is indeed 8 ohms. So look, I'll ask the customer if we want to try and source an original transformer 8 ohms from that era. It's going to be a very long, arduous search, and it's going to be very expensive. So he might be happy with it how it is. I'll ask him and go from there. All right, so just regarding the code on the speaker, 220535. So 220 is the EIA, which is Electronic Industries Association code for Jensen, the speaker division in particular. And the 4th digit represents the last digit of the year of manufacture. So this could be either a 1955 or a 1965, but we're leaning towards 55 and 35th week of 1955. Thank you, Six, or aka Dr. Gear, in the comments. A wealth of knowledge up in that little noggin of yours. And also thanks everyone for their brisket cooking tips. When I mentioned the brisket story in the aluminium foil, as you guys call it. All right, so just cleaning up the speaker wiring. I just desoldered it because there's a couple of broken strands there. I don't trust it. I want to re-terminate it. And this wire is pretty flimsy, to be honest, for speaker wire. So what I might do is just to reduce it flexing right where it's soldered, I know it's not very vintagey, but I'll put a little bit of heat shrink over it just to give it a bit of strain relief right where it exits that tag, and hopefully that will prevent it from breaking in the future. We'll keep the original wire because it's that look, but current carrying capability, man, that's hard to say. Current carrying capability, Captain, is not as much of a concern in this little tutor, but more the mechanical resilience of the wire. All right, there we go, champions. Doesn't look super vintage, but it instills a lot more confidence that those wires aren't going to break off right there at the tag. Look, if they had heat shrink back when they built this thing, I reckon they would have used it on fucking everything because it's an amazing material, and if they had it at their disposal back then, you would have seen it everywhere. All right, let's get this little bugger back in its cabinet. You can see there, they put big oversized fender washers on there. Fender washers, named after holding the fender on your car, I guess, because they're oversized. But you can see the original screws really sunken itself in. The cabinets are pretty soft pine, so if you over-tighten them, or just the general shock of all that mass from the transformer, that's all right, works fine, doesn't look original, but at least the screw won't sink in anymore. However, you can see from no use of a flat washer on the inside of the chassis, it has distorted a little bit in the screw hole there, so it is pretty crazy mounting these with just 2 screws, particularly the bigger units. So I'll just install a flat washer on the bottom there. You know what, champions, this never had any shields, so I just went looking through the little screw container there from when I first disassembled it, and then I looked at the notes, and yeah, missing shields. So I'll pull some from my stash. Just got some Beltons down there, which you'll squeeze on there, no problem. Beauty. The top one's bayonet actually fit perfectly, but the bottom one it just fits under tension. It was a pretty tight squeeze to get it on there, so just the friction will hold it on there alone. Right, so as discussed on the Champ video and earlier in this series, I diluted some Type Bond 1 to about 15% glue, 85% water. Gave it 2 applications of that, really let it soak in, and you could see it soaked it up like a sponge, really got into the grain. And even after doing that, it had sort of a sheen to it, but just to be sure, I gave it some undiluted glue, just did some spirals on top, and then brushed that in just to make sure it had a nice coating on there, no loose fibers letting go, and made sure in particular around the edge that it was all locked in. So the only way that would become hazardous again is if you went cutting it or drilling it and snorted the dust, you know, racked up a couple of lines on the bench, that kind of thing. So I've started putting some heat shields on here. I'll put one there for the valves so the valve won't continue to burn the tweed there. It'll reflect that heat. And now I'm going to shield the rest of them in the area of the chassis for shielding against noise and RFI, that kind of thing. So to do that, we've got a roll of this 0.5mm aluminium flashing, just Stanley blade, straight edge. I've already marked where I'm cutting. A couple of cuts, 1, 2, 3. That's usually enough. You can just bend it up, bend it a couple of times, and off she goes. Piece of piss, champions. Does eventually destroy your blade, but plenty more where that came from. They end up developing a bit of a hook on the end and they drag a bit. Alright, we'll put our offcuts aside. I'll use them on something else. No waste around here, champions. Alright, now I don't just staple, because then you might get some rattling during playing, and we don't want that unless you're in a 9-inch nails cover band. Bit of double-sided tape. They call this carpet tape in some areas. Nice, I think it's 50mm wide. You can overhang it a little bit and cut off the excess, or in this case there might just be a tiny gap between the 2 runs. Just use a cork block or a MDF block to work out the air bubbles. I've got a roller at home that I use for Tilex, but when you've got a workshop at home and a workshop at your workshop, you kind of need 2 of everything, and it sucks. It gets pretty expensive. You say to yourself, yeah, I'll just grab it from the home shop and take it in. You never remember to, champions. You always end up doubling back and picking stuff up or figuring out how you can get away with it, and eventually you get sick of that and you just buy 2 of everything. Right, we'll just peel off the backing, just line everything up. It's not as critical as contact glue. You don't have to, you know, pray to the gods of joinery that you get everything lined up correctly, because you can peel it off and correct if required. Alright, just give it a bit of a press down with the back of the block, and I like to sort of roll the edges so it doesn't catch on anything. Alright, it's pretty well stuck now. No rattling or anything, but just to bring it on home, I've got a little manual stapler here. It's great for shooting apprentices with in the joinery trade, but it's also good for, you know what I just realised, champions? I've run out of staples, and guess where they are? The home bloody workshop. That's right. Anyway, you get the idea.